Folks, welcome to Factoring Review. In this section, I hope that we will review some of the concepts of factoring quadratic equations. This should be a review from Algebra 1, so if you need any more help than what this video provides, please contact me and let me know, and I can provide you with more assistance. The goal is to help you be better prepared to deal with some of the problems that you will see throughout Chapter 3. Let's first take a look at factoring out a greatest common monomial factor. So what we're basically looking for is we're looking for the GCF. We're looking for the biggest number and variable that we can divide into both of these terms. So specifically, if I look here at the 12 and at the 15, I say, what is the biggest number that I can divide into 12 and 15? The answer to that, of course, is 3. So I can divide 3 into both of those numbers. So that's part of my GCF. Next, I look at the A's. A to the second and A. What's the biggest amount of A's that I can divide out of both of those? And of course, that is in fact just 1A. And now I look at the B's. What is the biggest amount of B's that I can divide into both of these terms? And of course, that is just 1B. Now, if I think about it, what times 3AB will give me 12a to the third b? And the answer to that is, let's see here, so 3 times what number will give me 12? 3 times 4 will give me 12. And a times what will give me a to the third? Well, let's hear a times a squared will give me a to the third. And what times b will give me b? Well, just 1, so I don't need another term there. Folks, we're kind of doing the opposite of the distributive property, right? So that's what we're trying to do to figure out what number goes in here. It's like if I applied the distributive property to this, what would I be left with? Okay, let's do the second term. Same idea. 3 times what will give me 15? 3 times what will give me 15? And the answer to that is 5. 3 times 5 will give me 15. Okay, a times what will give me a? Well, just 1, so there's no need for anything there. And b times what will give me b to the third? The answer is b squared. So I've done factored this. I'm done factoring this. If I wanted to, I could distribute that through and check my answer, but this is factored completely because I pulled out the correct GCF. Let's look at the second example. So what is the biggest number that I can divide into 2, 3, and 5? Well, there isn't one, so I don't have to worry about pulling out a numerical GCF. But what about my x terms? I have x to the third, x squared, and x. What's my biggest number of x's that I can pull out? And I can pull out 1x. So 1x can be pulled out. What am I left with? So x times what will give me 2x to the third? The answer is 2x squared. X times what will give me negative 3x squared? The answer, negative 3x. And finally, x times what will give me 5x? The answer, just a 5. Again, checking myself real quick, if I distribute it, that will in fact give me the original starting problem. At this point, I'd like you to pause the video, go to your factoring guided notes that we gave you, and I'd like you to try out this first section of problems, the greatest common monomial factoring. So I've done example 1 and 2 for you. Try out the 6 problems that are below that. Pause the video, and when you're done, we will continue through. Let's take a look at factoring the difference of 2 perfect squares. So very generically, the difference of 2 perfect squares always looks like this. It always looks like something squared minus something else squared. So what's really helpful is if you can recognize perfect squares. Perfect squares are like 1 squared, 2 squared, 3 squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and 16, 25, 36, 49, so on and so forth. It's helpful if you can recognize those values because it will tip you off that you're looking at a problem that is the difference of 2 perfect squares, something that is in the form a squared minus b squared. So if I look here at this first problem, x squared minus 64. 64 is 8 squared. So this one is actually written in the form of something squared minus something else squared. So in this case, x squared minus 8 squared. And in my shortcut rule, if it's written in the form a squared minus b squared, then I can factor it down to be a minus b times a plus b. So if I look at my original problem here, this x squared minus 64, I can see that a is equal to x and b is equal to 8. So when I factor this out, I would get x minus 8 times x plus 8. And that's it. That is the answer. I can't factor this down anymore. Let's look at the next problem. 16x squared minus 81. Well, let's see here. 16 is a perfect square. That's 4 squared. And of course, x. So this could be rewritten as the quantity of 4x squared minus, again, 81. 81 is a perfect square. That's 9 squared. So again, I have this situation where this is a and this is b. So I write this out. I have 4x minus 9 times 4x plus 9. The difference of two perfect squares. At this point, again, I'd like you to pause the video. I'd like you to take a look at your guided notes packet under section 2, the difference of perfect squares. I've done example 1 and 2 for you. You now have 6 problems to try out on your own. I will give you this warning. Don't forget, the first thing you should always try to do is factor out a monomial. Does it have a GCF? If it has a GCF, we want to make sure we factor that out first, and then proceed with trying to find the difference of two perfect squares. Pause the video, and when you come back, we'll go on to the next section, perfect square trinomials. For perfect square trinomials, these are always in the form a squared plus 2 times a times b plus b squared. So if we look at this first example, x squared minus 14x plus 49, we should be able to see that it's in this pattern. So let's see here. According to this, if I look there, the a value would be x, and the b value would be 7. So I should be able to write this as 2 times a times b. And if I look at it, 2 times x times 7 does give me 14x, so I'm good there. So again, a squared plus ab plus b squared, or you could also have it with a minus sign there. Okay? If it's written in this form, then we can factor it down to turn into a plus b times a plus b, or in the second example with that minus 2ab, it could be a minus b times a minus b. And again, if we wanted to simplify those down, we could use exponents. That's perfectly okay. So once I look at my equation and I can identify a and I can identify b, then this equation is very easy to factor. I get x minus 7 times x minus 7, or x minus 7 squared. This is a particularly helpful shortcut, especially when you get a problem like the second one, 16x squared plus 24 plus 9. If you identify a and you identify b, and you verify that that middle is 2 times a times b, and it is, 2 times 4 is 8 times 3, not 9 there, I'm sorry. 2 times 4 is 8 times 3 gets you 24. Then it's easy to factor. This would turn into 4x plus 3 times 4x plus 3, or 4x plus 3, that quantity squared. Either answer will work. Once again, pause the video now. Try out the perfect square trinomials section of your factoring guided notes. Try those 6 example problems. When we resume, we'll go on to the next section. We're now going to look at factoring trinomials when a is equal to 1. So you will not see a number here in front of the x squared value. We have to modify our process just a little bit when we have a number that's right here in front of the x squared. So I want to remind you what we're looking for when we're factoring at trinomials. We're looking for numbers that multiply together to give me 15 and add together to give me 8. So when you're in doubt, start writing out all the numbers that multiply together to give you 15. So what numbers multiply together to give me 15? Let's see here. There's 1 and 15. There's 3 and 5, and that's pretty much it. So when I'm looking at this, then I have to determine which pair of these numbers adds together to give me 8. The answer to that, the numbers that give me 8 is 3 and 5. So this gives me the factors, x plus 3 times x plus 5. Now, if you forget this, there was another way that you could do it where you could come up with your box. and the 15 would go here, and the 8 would go here, and we're still looking for the pair of numbers that multiplies together to give me the top value, but adds together to give me here. So multiplies to give me 15, but adds together to give me 8. And the pair of numbers that does that is 3 and 5. That doesn't change my process, and those numbers, of course, go here and here when I'm factoring out. If I go over here to the second problem, x squared minus 11x plus 30, and I use my x, right? I'm looking for numbers that multiply together to give me 30 and add together to give me negative 11. Let's see here. The numbers that multiply together to give me 30 but add together to give me negative 11. Numbers that multiply together to give me 30 are, let's see here, we got 1 and 30, we have 2 and 15, we have 3 and 10, 4 doesn't work, we have 5 and 6. But none of these will add together to give me negative 11. 5 and 6 add together to give me positive 11, but not negative 11. So you have to remember that this is positive 30, which means negative 1 and negative 30 work. Negative 2 and negative 15 work. Negative 3 and negative 10, negative 5 and negative 6. And once I remember my negatives, here are the two numbers that give me negative 11. So my values are negative 5 and negative 6. So when I factor this, I get x minus 5 times x minus 6. You can really quickly check yourself. You can check yourself by foiling if you wanted to. So check by foiling. So if I had x minus 5 times x minus 6, and let's see, I did the firsts, and then I did the outsides, and the insides, and the lasts, I would very quickly be able to verify that my answer is in fact correct. All right. Again, time to pause the video. You're going to do the section number 4 in your guided notes, factoring trinomials when a is equal to 1. When we resume, we'll go on to section 5. For factoring trinomials when a is not equal to 1, notice we have a number here in front of my x squared. We have to modify our process just a little bit. So instead of looking for numbers that multiply together to give me c, I'm looking for the pair of numbers that multiply to give me a times c. In this particular problem, that is 6 times 4, which is 24. So I look at all the pair of numbers that multiply together to give me 24. So let's see here, that's 1 and 24, that's 2 and 12, that's 3 and 8, that's 4 and 6. And I'm looking for the pair of numbers that will add together to give me b. That still remains the same. So that pair of numbers is 3 and 8. So what does that mean? That means that when I'm going to factor this out, I have to actually, there's an additional step here where I have to split that middle term, that 11x, I have to split it up into the two numbers that I just found. So the two yellow numbers are what I'm coming up with here, the 3x plus the 8x. That's coming from the values that I came up with right here. They go down here. Then what I do is I have to factor by grouping. So I look at these first two terms and I say, what can I factor out of 6x squared and 3x? A 3x is what I can factor out. And when I do, I'm left with 2x plus 1. In the second two terms, I look again and I say, what can I factor out of 8x and 4? The answer is 4. What am I left with? 2x plus 1. You should notice that these two parentheses match. And if they don't, you need to go back to the drawing board. You probably made a mistake. Since they do, that is one of our factors of this quadratic equation. The other turns out to be the leftover terms that are in front, the 3x and the 4. Again, I got that from here, that goes here, and I got the 4 from right here. Okay? If we did this with our x box like we did before, our x box, it's still a times c and b here. And we'd still come up with the same values that we did before. So what multiplies together to give me 24, adds together to give me 11. I'd come up with the same numbers 3 and 8. But as I said, we also have to do an additional step with this. We have to do a box. So maybe you learned how to do this x box method. So again, if we do x box method, then what we're going to do at this next step is we're going to take our first term and stick it in this box, and our last term and stick it in this lower right-hand box. And then my two numbers that I came with here are going to go in these diagonal boxes. Notice that this diagonal right here, this diagonal adds together to give me my middle term. That's pretty important. Okay, now I look for the GCF. I look for the biggest number that I can divide into both of these terms. Okay, what is that? What can I divide into 6x and 8x? Well, the biggest thing I can divide into both of those is 2x. I'll do the same thing down here. I'll do the same thing down here with my 3 and my 4. What's the biggest thing that can divide into 3 and 4? Well, nothing. That's just a 1, so a positive 1. Then I will look up and down, and I'll say, what's the biggest thing I can divide into 6x squared and 3x? The answer to that, 3x. And finally, the last one. I look at the biggest thing that I can divide into 8x and 4. The biggest thing that I can divide into 8x and 4 is 4. A positive 4. Now, if you look, this becomes my first factor, and this becomes my second factor. Let's take a look at another example. Okay, here we have 5x squared minus 17x plus 12. We're going to repeat that same process that we did the last time, and I'll show you how to do this both ways, using both Xbox as well as that kind of uncombining like terms and using that factoring by grouping method. Let's do Xbox first this time. So I'll draw my little x, and I know up here it's a times c, and down here it's b. So I'm looking for the pair of numbers that multiplies together to give me 5 times 12. 5 times 12 is 60. And I'm looking for the numbers that multiply together to give me 60 and add together to give me negative 17. Now this one's a little harder. I got to think a little bit more. I'm going to have to figure out what numbers will multiply together to give me 60. So let's see here, 60. 1 and 60. Let's see here, 2 and 30. Let's see here, 3 and 20. 4 and 15 will work. 5 has to go in there, so I see 5 and 12, of course. Well, that's the same one I did it. 6 and 10. 7 doesn't go in. 8 doesn't go in, so my list is complete. Now, since I'm looking for negative 17, well, I got to find the pair of numbers that adds together to give me 7, negative 17. And if I look, I know I don't have negative signs there, but negative 5 and negative 12, if I put them together, that will give me positive 60 and add together to give me negative 17. So this is my pair of numbers. So negative 5 and negative 12. So again, if I'm looking and doing Xbox, then now I draw my box, right? I did my X, now it's time for my box. And in the upper left, I write the first term, 5x squared. And in the lower right, the 12. And then this 5x, or this negative 5x goes here, and this negative 17x goes here. And I'm looking for the pair of numbers that each row and each column has in common. So what do I see in common here? Well, let's see here, 5x squared and 17x. What would the GCF be? Just x. That's all I can see there. What about here? What about negative 5x and 12? Well, since the negative sign leads there, I remember that means that this means this has to be negative, and let's see, 5 and 12, nothing goes in there. So 1. Okay, so what about here? What about here in this first column? What does 5x squared and negative 5x have in common? And of course, that answer would be a 5x. And then finally, the last column, what do negative 12x and 12 have in common? And that, of course, would be a negative 12. And again, negative because the term right here is, in fact, negative. That's a negative sign right there. So this gives me my two factors, x minus 1 and 5x minus 12. Now, if I did this same problem, 5x squared minus 17x plus 12, if I did that the other way, I'm still looking for that pair of numbers that multiplies together to give me 60 and adds together to give me negative 17. I would still end up with the same values of negative 5x and negative 12. So what ends up happening? That ends up me taking this middle term, right, this negative 17x, and splitting it into negative 5x and negative 12x. Again, I finish it out plus 12. And now I look at my first group and my second group, and I factor each one of those by grouping. So what does my first group have in common? What does 5x squared and negative 5x have in common? Let's see here, a 5 and an x. So I'll factor out the 5x. What am I left with? X minus 1. I look at my second group, the negative 12x plus 12. What do they have in common? I see a negative 12 that they have in common. What am I left with after I divide out the negative 12? X minus 1. You'll see that these two parentheses match. I write those once, and then the leftover stuff goes into my second parenthesis. You'll see that both of my answers match. That's two different ways to do this. So, at this, pause the video and try the practice problems. I did that last set of example problems. You have 6 more problems to try. If you have any questions, please don't hesitate to ask. Otherwise, good luck. Thanks for watching.